In today's session, we're going to learn about collision theory. We're going to look at what collision theory is. We're going to be able to list the 5 factors that affect rate of reaction. And we're going to explain how each of these factors affects rate of reaction. So what is collision theory? Collisions happen between particles all the time, but a reaction won't occur unless we have enough successful collisions. If we have enough successful collisions, a reaction will occur. But we need to look at 2 things in particular. The frequency of collisions has to be mentioned in all your answers, and the speed of the reaction has to be mentioned too. So if there's more frequent collisions, there'll be a faster rate of reaction. If there's less frequent collisions, you'll have a slower rate of reaction. You'll be asked short answer questions where you'd probably have to come up with the names of the 5 factors that affect rate of reaction. So you need to learn these off by heart. The first one is surface area, then temperature, catalysts, concentration, and pressure. I'll show you how each of these affect rate of reaction. Over the next few lessons, we'll go through some of the practicals to do with these factors, but we'll get the theory done in this lesson or this session. Right, so we'll start with temperature here. Temperature, easy to understand because we've done work on particles before. And in physics, you should have learned about how particles move faster when they're heated up and slower if they're cooled down. So, if we increase the temperature to 70 degrees Celsius, the particles have more thermal energy, which they convert to kinetic energy, meaning they move around a lot more, and there's a higher chance of collisions. We have to talk about our increased frequency of collisions, and therefore faster rate of reaction. With the temperature decreasing down to 10 degrees Celsius, we have less particles colliding, less frequent collisions, and a slower rate of reaction. Collisions happen on surfaces. So if we had more surfaces available, we would have faster reactions. So I always use this diagram to help me remember this. Let's say we got a 4 gram cube. Let's pretend this is a cube. If we look at the number of surfaces available for collision, they're very limited. But if we crush this substance into smaller pieces, still weighing the same mass, look what happens. We have more surfaces available for collisions. And because of that, we'll have more frequent collisions and a faster rate of reaction. Remember, the smaller the pieces, the faster the reaction. It's not about just crushing the pieces smaller though. If we've got 2 different shapes, we could look at the number of surfaces that they have, and that will increase the rate of reaction or decrease the rate of reaction based on the number of sides. So this square only has 4 sides. This polygon here has many sides, so many surfaces. This has a larger surface area than this. This will have more frequent collisions compared to this, a faster rate of reaction compared to this. Catalysts speed up rates of reaction. I'll show you how. If we draw a normal exothermic reaction profile, reactants here, products here, and then activation energy is normally from here to here, isn't it? So we'll label that on EA. Now, what happens when we add a catalyst is that it lowers the activation energy. And when you draw it in the exam, you have to draw it with this dotted line or with a line that's underneath, and it starts at the same place and it finishes at the same place, but it shows a lowering of the activation energy. We label this EA catalyst. Because the energy needed to start the reaction is lower, we need fewer collisions for this reaction to start. This is economically good for industry because less energy is needed to start a reaction. When there's a high concentration of something, there are more particles available for collisions. When there's less particles available for collisions, the reactions will be slow. Where there's more particles available for collision, the reaction will be fast. If we look at these two diagrams, we've got diagram A and diagram B. We've got more reactant particles in diagram B, so the rate of reaction will be faster because there's more chance of collisions, more frequent collisions. Do you notice the use of the word frequent collisions, chance of collisions? You have to use that in your answers when you write them down. Pressure is built up when particles collide with the sides of their containers. If we had a low pressure, reactions will be slow because there's less frequent collisions, so slower rate of reaction. At high pressure, like in diagram B here, there's more particles available for collisions in terms of with the sides of their containers, so the pressure will be greater. Increased pressure means a faster rate of reaction. Decreased pressure means a slower rate of reaction.